Welcome to The Sleepy Scientist, where curiosity meets comfort in the quiet hours of night. Tonight, from wherever you are watching, perhaps nestled in your favorite chair, lying beneath soft blankets, or finding a moment of peace in your busy world, we embark on a journey through one of science's most captivating mysteries, the nature of time itself. Feel your body settling now, like a leaf finding its place on still water. Your shoulders release their hold on the day's tensions. Your breathing finds its natural rhythm, slow and steady as ocean waves against a peaceful shore. This is your time, sacred, unhurried, yours alone. As you settle into this moment, notice how the world around you transforms. The harsh edges of daylight concerns soften into gentle shadows. The urgent voices of daily life fade to whispers, then to silence. In this quiet space, your mind begins to open like a flower turning towards starlight, ready to receive wonder. Tonight, we'll explore whether the dream of time travel, that persistent whisper in human imagination, might actually be woven into the very fabric of our universe. But we won't rush toward answers. Instead, we'll drift like astronauts in the weightless realm of possibility, letting questions bloom slowly in the garden of your consciousness. Think for a moment about time itself. Right now, as you breathe in, this moment arrives, fresh and new. As you breathe out, it becomes memory, joining the vast constellation of all your previous moments. Time flows around you like an invisible river, carrying you forward on currents you cannot see but always feel. Yet what if this river has hidden depths, secret channels where the current might flow backward or sideways, or loop upon itself like water in a gentle eddy? What if the very ground beneath time's flowing contains doorways to yesterday and tomorrow? Let your eyelids grow heavy as we prepare to drift through the gentle currents of scientific discovery, where Einstein's insights meet the rhythm of your heartbeat, and where the impossible becomes beautifully, mysteriously possible. In the soft darkness behind your closing eyes, we begin to glimpse the first hints of time's deepest secret, that it may not be the straight arrow we imagine, but something far more wondrous and strange. Close your eyes and feel the gentle current that carries you through this moment. Time flows around you like an invisible river, and you are both the boat and the passenger, drifting along its mysterious course. Right now, as you breathe in slowly, and exhale even more slowly, you are traveling through time at exactly 1 second per second. One heartbeat after another, moving steadily from the past into the future. But what if this river could change its direction? Time feels so natural, so obvious, that we rarely pause to wonder about its true nature. Your pulse marks its rhythm. Your memories trace its path backward. Your hopes reach forward into its unknown waters. Yet this river that seems so constant, so unchanging in its flow, holds secrets that would have seemed like magic to our ancestors and still feel miraculous today. Imagine for a moment that you could step outside this current, like climbing onto the riverbank of time itself. From this vantage point, you might see the entire stream laid out before you passed, present and future flowing together in one vast, eternal landscape. You might watch your younger self learning to walk, while simultaneously observing your future self decades from now, both existing in the same timeless moment. This isn't fantasy. This is the profound reality that science has gradually revealed. To us, time, that most familiar companion of your daily existence, is far stranger and more malleable than our everyday experience suggests. It can stretch like warm honey on a summer day. It can compress like a spring under pressure. It can curve and bend, and perhaps, under the right circumstances, even flow backward. Think about how time already changes for you in small, personal ways. When you're absorbed in something you love, hours pass like minutes. The river of time seems to rush beneath you, carrying you swiftly forward without your notice. But when you're waiting, when you're bored or anxious, each minute stretches endlessly. The current slows to barely a trickle, and you feel suspended in amber, watching the clock's hands crawl across its face. Your body knows time in its own deep way. Your cells follow circadian rhythms older than written history, rising and falling with patterns encoded in your DNA. Your heart beats roughly once per second when you're at rest, marking time like a biological metronome. Your brain creates memories by encoding the sequence of moments, building your personal timeline, neuron by neuron, synapse by synapse. But even within your own experience, time plays tricks. In dreams, you travel freely, through temporal landscapes that make no logical sense. You might find yourself as a child in your current home, or elderly in a place from your youth. You wake up having lived hours or days in the space of a few sleeping minutes. Your mind, it seems, already knows how to navigate time in ways that transcend the simple forward march of waking consciousness. Scientists have discovered that your brain doesn't experience time as a steady stream, but as a series of snapshots, like frames in a movie, that it weaves together into the illusion of continuous flow. Each now moment actually lasts about 3 seconds in your perception, a window during which your mind gathers sensory information and constructs your experience of the present. Between these windows, your consciousness jumps forward in time, creating gaps you never notice, moments you never experience. This reveals something profound. Even your personal experience of time is more fluid, more constructed than it appears. If your own brain can edit time, slowing it down in crisis moments or speeding it up during flow states, perhaps time itself is more flexible than we imagine. Consider how memory makes you a time traveler every day. When you recall your childhood, you don't just think about the past, you visit it. The neurons firing in your brain recreate patterns from years ago, allowing you to taste again the birthday cake from when you were 7, to feel the texture of your first pet's fur, to hear the specific quality of rain on the roof of a house. You no longer live for those moments of remembering. The past becomes present, and you exist simultaneously in multiple points along time's river. Even more mysteriously, your brain sometimes seems to glimpse the future. Experiments have shown that your unconscious mind can begin reacting to events before they happen, before your conscious awareness catches up. Your body knows to duck before your mind recognizes the thrown ball. Your emotions shift before you understand why. It's as if some part of you already lives a few seconds in the future, sending messages backward to prepare your present self. These hints suggest that time might not be the rigid, one-way street it appears to be from your everyday perspective. The river metaphor, beautiful as it is, might not capture the full reality. Perhaps time is more like an ocean, with currents flowing in multiple directions, with depths we haven't explored and territories we haven't mapped. The ancient philosophers wondered whether time was real or illusory, whether it had a beginning or had always existed, whether it would have an end or continue forever. These questions, once purely philosophical, have become scientific investigations. We now have instruments that can measure time dilation, proof that time passes differently in different circumstances. We have mathematical equations that suggest closed loops in time, pathways that might lead back to their own beginning. As you lie here in the gentle darkness, feeling your breath create its own rhythm, independent of clocks and schedules, You are participating in one of the universe's deepest mysteries. Your consciousness rides along time's current, experiencing each moment as it arrives, unable to speed up or slow down at will, unable to turn around and swim upstream. But science whispers that this might not always be the case. The equations that govern reality contain provisions for time travel, pathways through the mathematics that could, under extraordinary circumstances, allow movement backward and forward through time's landscape. These aren't violations of natural law, but expressions of deeper patterns woven into the very fabric of space and time. Tonight, as we drift together through this exploration, you'll discover that the river of time is far more mysterious than it first appears, and that the dream of traveling through it might be written into the fundamental laws of physics themselves. But first, we must meet the gentle genius who first showed us that time could bend. Picture a gentle man with wild silver hair and eyes that sparkled with curiosity, sitting by a window in Switzerland over a century ago, watching the world with the wonder of a child who never stopped asking, what if? This was Albert Einstein. And as you rest here in the quiet darkness, breathing slowly and letting your mind drift, you can imagine him in that moment when everything changed, not through violence or force, but through the simple, revolutionary act of thinking differently about the most basic things we take for granted. Einstein looked at space, that vast emptiness that surrounds you even now, and at time, that invisible current carrying you from moment to moment. And he realized something extraordinary. They weren't separate things at all, but partners in an eternal dance, woven together into a single, flowing fabric he called space-time. Before Einstein, people imagined space as an empty stage where events played out, and time as a cosmic clock ticking uniformly throughout the universe, measuring the same seconds and minutes for everyone, everywhere. But Einstein, with the gentle persistence of someone who trusted his intuition more than conventional wisdom, suggested that space and time were more like lovers who could never be separated, who influenced each other constantly, who bent and stretched and curved in response to the matter and energy moving through them. He showed us that when you move very fast, not the kind of fast you experience in a car or even an airplane, but truly fast, approaching the speed of light itself, time begins to slow down for you, relative to someone standing still. It's not that you feel time moving differently. To you, everything seems perfectly normal. But if you could somehow watch a friend who stayed behind while you traveled at nearly light speed, you would see their life unfolding in slow motion, their clocks ticking lazily, their movements languid and dreamlike, while they would see you moving and aging normally from your own perspective. This isn't science fiction or philosophical speculation. It's been proven thousands of times with atomic clocks carried on aeroplanes, with particles accelerated in laboratories, with the GPS satellites that help you navigate, which must constantly adjust their timing because they experience time slightly differently than we do here on Earth's surface. Einstein also revealed that massive objects, planets, stars, anything with significant mass actually bend the fabric of space-time around them, creating curves and dips like a bowling ball placed on a stretched rubber sheet. What we experience as gravity isn't really a force pulling us downward, but the natural result of moving through curved space-time, like a marble rolling along the depression created by that bowling ball. And in these curves, time itself moves differently, more slowly in deeper gravitational wells, more quickly in the shallower regions farther from massive objects. Right now, as you lie comfortably wherever you are, the time you're experiencing is moving ever so slightly more slowly than time would move if you were floating in the emptiness between galaxies, because Earth's mass creates a gentle well in space-time that affects the flow of time itself. Your feet, being closer to Earth's center than your head, are actually aging a tiny bit more slowly than the rest of you, an effect so small it would take billions of years to notice, but real. Nonetheless, measurable with precise enough instruments. Einstein's equations, elegant and beautiful as poetry, contain within them the mathematical pathways for time travel, solutions that allow for closed time-like curves where cause and effect might loop back on themselves, where the river of time might bend into circles or figure eights or more complex geometries that our everyday experience can barely imagine. These aren't mistakes in the mathematics, but natural consequences of the way space-time behaves when it encounters extreme conditions, massive objects spinning rapidly, wormholes connecting distant regions of space, cosmic strings stretching across the universe like the fundamental fabric of reality itself made visible. What makes Einstein's revolution so profound is not just that he changed our understanding of space and time, but that he did it with such gentleness, such respect for the beauty and interconnectedness of everything. He didn't tear down the old ideas with violence, but showed us a larger, more complete picture that contained the previous understanding as a special case. The way a photograph of your entire house contains within it a perfect image of your bedroom window. In his world, nothing is absolute except the speed of light and the curvature of space-time, and everything else distance, duration, simultaneity, the very flow of time itself becomes relative, dependent on your point of view, your speed, your position in the gravitational landscape of the universe. As you drift deeper into the peaceful rhythm of your breathing, feeling your heartbeat mark time in its ancient, reliable way, you are experiencing Einstein's universe directly, living within the curved space-time that he first imagined, aging slightly differently than you would in a different gravitational field, moving through time at a rate determined by your velocity, through space in your position in Earth's gentle gravitational embrace. His insights opened doorways in our understanding that we're still walking through today, pathways that lead toward questions about whether we might someday learn to navigate these curves and currents of space-time deliberately, whether the time travel that lives in the mathematics might eventually become as real and tangible as the gravitational time dilation that's already affecting you in this very moment. Tonight, as we continue our journey through the science of temporal possibilities, we'll meet two twins whose story demonstrates Einstein's insights in the most personal, human way possible, showing us how time itself can become a bridge between hearts separated by the vast distances of space. Imagine two children born on the same day, in the same hour, sharing their first breath and their first heartbeat almost simultaneous latents, whose lives begin as mirror images of each other, whose cells divide and grow in perfect synchronization, whose biological clocks tick with identical rhythm as they learn to walk, to speak, to dream about the vast universe stretching endlessly above their heads. Let's call them Alex and Jordan, and as you settle deeper into your comfortable position, feeling the gentle weight of blankets or the soft support of your pillow, picture these two souls growing up together, sharing birthdays and scraped knees, and whispered secrets, their timelines perfectly parallel until the day when Jordan looks up at the stars and decides to touch them. Jordan becomes an astronaut, not the kind we have today who orbit Earth for months at a time, but an explorer of the far future when humanity has learned to build ships that can approach the speed of light itself, vessels that can carry a human being across the vast distances between stars in voyages that would take ordinary ships thousands of years to complete. Alex chooses to stay on Earth, to build a life among familiar gravity and known seasons, to tend a garden and watch sunsets and wait for Jordan's return. And so their paths diverge not just in space, but in time itself, because Einstein's gentle revolution has woven speed and time together so intimately that Jordan's journey among the stars will stretch and compress the very fabric of temporal experience. When Jordan's ship accelerates to 90% of light speed, something beautiful and strange begins to happen from Alex's perspective on Earth. Jordan's life begins to slow down like a movie played at half speed, their heartbeat lengthening, their movements becoming graceful and dreamlike, their aging process stretching out over years that pass normally for Alex, but feel perfectly normal to Jordan, who experiences every moment of the journey as completely ordinary, eating meals and sleeping and thinking and feeling exactly as they always have. This is the profound mystery of Einstein's time dilation. Jordan doesn't feel time moving differently during the voyage, doesn't experience any sensation of temporal strangeness, because within their own reference frame, their own personal bubble of space-time, everything proceeds at its normal pace. But when measured against Alex's time back on Earth, Jordan's entire existence has entered a different temporal rhythm, a slower dance with the universe that will have consequences neither twin fully anticipated when they said goodbye. Jordan's journey to a star 20 light-years away and back might take 40 years from Alex's perspective, for decades of birthdays and seasons and gradual aging, of watching their reflection change in mirrors and feeling their bodies settle into the comfortable patterns of middle age. But for Jordan, traveling at such tremendous speed, the voyage might subjectively last only 10 years, a decade of exploration and wonder during which their body ages only 10 years while Alex's ages 40. When Jordan finally returns to Earth, slowing down from their incredible velocity and feeling the familiar tug of home planet's gravity, they step out of their ship to find Alex waiting with hair gone grey and lines around their eyes that speak of 4 decades of patient longing, while Jordan appears almost exactly as they did when they left. Perhaps with a few more years written in their face, but still recognizably, the young explorer who once looked up at the stars with wonder. This isn't science fiction, but the direct, inevitable consequence of the way space-time behaves when objects move at speeds approaching light. And the mathematics that predict this outcome have been tested countless times with particles and atomic clocks and satellites, proven to be as reliable as any natural law we know. The twins' reunion would be both joyful and melancholy, a celebration of love that transcended time itself and a recognition that their shared timeline, once perfectly synchronized, has been permanently altered by Jordan's journey through the curved landscape of relativistic physics. They would have stories to share across the gap of their different temporal experiences. Alex, speaking of decades of Earth's changes, the people met and lost, the slow evolution of technology and culture and the natural world, while Jordan describes alien sunrises and the profound silence of interstellar space and the way stars look when you're moving fast enough to shift their light into new colors across the electromagnetic spectrum. Their experience illustrates something profound about the nature of time travel. It's not just possible, but inevitable once you begin moving at relativistic speeds, though it's a one-way journey forward into the future rather than the backward travel that fills our stories and dreams. Jordan has effectively traveled into Alex's future, skipping over 30 years of Earth's timeline and emerging into a world that has aged around them while they remained relatively young, a time traveler. not by choice, but by the simple consequence of velocity and the curvature of space-time around massive objects. The twin paradox, as physicists call this thought experiment, reveals that time travel into the future isn't just theoretically possible, but practically inevitable for anyone who travels fast enough or spends time in gravitational fields different from those they started in. And while the effect is usually too small to notice in our everyday lives, it's constantly happening on tiny scales with every aeroplane flight, every drive to a mountaintop, every moment spent at different altitudes, where gravity's pull varies by measurable amounts. As you rest here in the gentle darkness, your own body participating in these subtle temporal effects as Earth spins and orbits and carries you through the gravitational landscape of the solar system. You can imagine Alex and Jordan in their later years, their love deepened rather than diminished by their strange temporal journey, sharing quiet evenings where they compare their different memories of the same calendar years, marveling at how Einstein's insights allowed them to experience time as a malleable dimension rather than an absolute constraint. Their story leads us naturally to wonder about the force that made Jordan's time travel possible in the first place. The invisible influence that curves space-time itself and creates the gravitational wells where time flows at different rates, drawing us deeper into the mystery of how massive objects shape not just space but the very passage of time itself. Feel the gentle pressure of gravity holding you in this moment, the soft weight of your body against whatever surface supports you, and realize that this familiar force that keeps your feet on the ground and your coffee in your cup is also reaching through the fabric of space-time itself to slow down time around you in ways so subtle yet so profound that your very existence depends on them. Gravity isn't just pulling you toward Earth's center, it's actually bending the dimension of time, creating curves and wells in the temporal landscape that make your heartbeat tick at a slightly different rate than it would if you were floating weightless in the vast emptiness between galaxies. And this effect, predicted by Einstein and confirmed by the most precise atomic clocks humanity has ever built, means that every massive object in the universe is a time machine, warping the flow of temporal experience simply by existing. Your feet, pressed closer to Earth's center than your head, are aging infinitesimally, more slowly than the rest of you, experiencing time dilation that amounts to mere billionths of a second over a human lifetime, but represents a real, measurable difference that GPS satellites must account for to maintain their accuracy, because those satellites, orbiting 20,000 kilometers above your head, experience time flowing about 45 microseconds faster each day than clocks on Earth's surface, a tiny difference that would accumulate into navigation errors of several kilometers if not constantly corrected. The deeper you descend into a gravitational well-weather that's moving from a mountaintop to sea level, from Earth's surface toward its core, or from empty space toward a massive star, the more slowly time passes relative to regions of weaker gravitational influence, as if time itself becomes thicker, more viscous, flowing like honey instead of water through the curved channels that massive objects create in the fabric of space-time. Imagine standing at the base of a tremendous waterfall where time flows down from the heights like liquid silver, cascading past you in streams that grow slower and more concentrated as they approach the gravitational source, pooling in deep temporal eddies where seconds stretch and minutes expand, and the very rhythm of existence shifts into a lowered, more measured cadence that feels perfectly normal to you, but appears dreamlike and languid to anyone observing from higher gravitational ground. This is happening right now as you rest here. Your biological processes, your cellular repairs, your neural firing patterns, the quantum fluctuations in your atoms are all participating in a cosmic dance with gravity that influences the rate at which you move through time, though the effects are so gentle and uniform throughout your body that you experience them not as temporal strangeness, but simply as the normal flow of your existence. Near truly massive objects like neutron stars or black holes, these effects become dramatic enough to create temporal landscapes that would seem magical if they weren't grounded in the most fundamental mathematics of space-time geometry. A clock on the surface of a neutron star would run noticeably slower than one held in your hand, and near the event horizon of a black hole, time dilation becomes so extreme that a falling observer would appear to an outside viewer to freeze in time, their image redshifted and dimmed, but never quite disappearing, suspended forever at the threshold between normal space-time and the infinitely curved interior where time and space exchange roles in ways that challenge our deepest intuitions about the nature of reality. The most beautiful aspect of gravitational time dilation is how it reveals the intimate connection between matter, space, and time. Mass doesn't just occupy space or move through time, but actually reshapes the fundamental geometry of both dimensions, creating a universe where the presence of matter curves the stage on which all physical events play out, where your body's modest gravitational field creates its own tiny distortion in space-time that influences the temporal experience of everything around you, though at scales far too small for ordinary perception. Scientists have measured these effects with atomic clocks carried up mountains and down mines, confirming that time truly does flow at different rates depending on gravitational strength. And they've observed gravitational time dilation in the light from distant stars, seeing how photons climbing out of deep gravitational wells lose energy and arrive at our telescopes redshifted, carrying information not just about the star's composition and temperature, but about the curved temporal geography through which their light has traveled across cosmic distances. As you breathe slowly and feel the comforting presence of Earth's gravity holding you gently in place, you're experiencing one of the universe's most profound secrets, that time is not a uniform background against which events occur, but a dynamic, malleable dimension that responds to the presence of mass and energy like a vast, invisible ocean whose currents and depths and hidden movements shape every moment of your existence. Your personal journey through time is being guided not just by the biological rhythms of your heart and lungs and neural oscillations, but by the gravitational fields of every massive object in your cosmic neighborhood, Earth's substantial bulk, the moon's gentle tug, the sun's dominant influence, the distant pull of Jupiter and Saturn, even the collective gravitational effect of our galaxy's central black hole, all contributing to the precise rate at which you age and experience the passage of moments. This gravitational choreography of time suggests profound possibilities for temporal exploration. If time flows differently in different gravitational environments, then traveling between those environments becomes a form of time travel, allowing future space explorers to experience temporal effects that would have seemed like pure fantasy to previous generations, but represent natural consequences of moving through the curved landscape of Einstein's spacetime. Tonight, as we continue our gentle exploration of time's mysteries, we'll discover how these curves in spacetime might be folded and connected in ways that create shortcuts not just through space, but through time itself, pathways that could theoretically allow travelers to emerge from tunnels in the fabric of reality, having journeyed not just to distant places, but to distant moments, following routes through space-time that challenge our understanding of causality and open doorways to temporal adventures beyond our current imagination. Picture the universe as an infinite sheet of silk stretched taut across dimensions you cannot see. And now imagine gently folding this cosmic fabric so that two distant points, perhaps your current location and a star system thousands of light years away, suddenly touch each other through the folded space between them, creating a bridge that exists not in the ordinary three dimensions of your daily experience, but in the deeper geometry of space-time itself. A tunnel through the mathematical landscape of reality that physicists call a wormhole, and that represents one of the most elegant and mysterious possibilities hidden within Einstein's equations. As you rest here in the gentle darkness, breathing slowly and letting your mind drift toward these profound concepts, you can envision space-time not as the flat, empty stage that our ancestors imagined, but as a dynamic, malleable medium that can be bent, twisted, folded, and possibly even punctured to create shortcuts between regions of space and time that would otherwise remain forever separated by vast cosmic distances and the limitations of light-speed travel. The mathematics that describe these hypothetical tunnels emerged naturally from Einstein's general relativity when physicists began exploring the most extreme solutions to his field equations, discovering that under certain extraordinary conditions, the curvature of space-time could become so pronounced that it creates what they call an Einstein-Rosen-Bridger throat, connecting to separate regions of the universe through a passage that exists outside the normal flow of three-dimensional space, allowing a traveler to enter at one location and emerge at another without ever crossing the intervening distance in any conventional sense. These wormholes wouldn't just be shortcuts through space, but potentially pathways through time itself. Because in Einstein's universe, space and time are so intimately connected that any dramatic manipulation of spatial geometry necessarily affects temporal flow, meaning that a journey through a wormhole might deliver you not only to a distant location, but to a different moment, either in your own past or future, or in the complex temporal landscape of some other reference frame entirely. The most beautiful aspect of wormhole physics is how it transforms our understanding of distance and separation. Two points that appear impossibly far apart when measured along the curved surface of space-time might actually be nearly touching when viewed from the perspective of higher dimensions, like two cities on opposite sides of Earth that seem incredibly distant until you realize you could drill a tunnel straight through the planet's core and connect them with a passage much shorter than any surface route. If such cosmic tunnels exist naturally in the fabric of space-time, they would likely be incredibly small, perhaps no larger than subatomic particles, and probably unstable, collapsing almost instantaneously under their own gravitational effects, unless they were somehow held open by exotic forms of matter or energy that possess negative mass or negative energy density, substances that theoretically could exist according to quantum field theory but have never been observed or created in any laboratory. The engineering challenges of constructing or maintaining a traversable wormhole would be so immense that they stretch the boundaries of what any conceivable technology could accomplish, requiring the manipulation of matter and energy on scales that dwarf our current capabilities and demanding a mastery of space-time geometry that we can barely imagine. Yet the fact that such structures appear to be mathematically possible within the laws of physics as we understand them suggests that the universe might contain doorways and passages that could revolutionize not just transportation, but our entire relationship with space and time, even if naturally occurring wormholes exist somewhere in the cosmos. Finding them would present extraordinary challenges. They might be scattered randomly throughout space, like cosmic pinholes, invisible except for their subtle gravitational effects, detectable only by the way they bend light or distort the motion of nearby objects, hidden in the vast darkness between stars or concealed within the event horizons of black holes, where no conventional observation could reach them. The journey through a wormhole, if such a passage could somehow be traversed safely, would be unlike any human experience we can fully comprehend. You might enter through an opening that appears no larger than a doorway, but find yourself traveling through a tunnel that connects to cosmic regions billions of light years away, experiencing the passage not as movement through ordinary space, but as translation through dimensions that exist perpendicular to our normal reality, emerging into a realm where familiar constellations have been replaced by entirely alien star patterns, and where the very flow of time might follow different rhythms than those you knew in your original location. Some theoretical physicists have proposed that advanced civilizations, if they ever developed sufficient understanding of space-time engineering, might learn to create artificial wormholes by carefully manipulating the quantum vacuum, or by concentrating exotic matter in precisely controlled configurations, essentially weaving new connections into the fabric of reality and creating transportation networks that would allow instantaneous travel between distant points in space and time. Though such achievements would represent a level of technological sophistication so far beyond our current capabilities that they belong more to the realm of scientific speculation than practical planning. The profound implications of wormhole physics extend beyond mere transportation to touch fundamental questions about causality, identity, and the nature of existence itself. If you could travel through a wormhole that connected your present moment to your own past, would you encounter a younger version of yourself? And what would happen if your actions in that past created changes that affected the very timeline you originally came from, leading to paradoxes and logical complications that challenge our basic understanding of cause and effect? As you drift deeper into the peaceful rhythm of your breathing, contemplating these vast possibilities hidden within the mathematical structure of space-time, you're touching one of the most beautiful intersections between human imagination and scientific discovery, where the ancient dream of instantaneous travel meets the elegant equations of modern physics to suggest that the universe might indeed contain secret passages through the landscape of space and time, doorways that could theoretically allow conscious beings to step outside the normal constraints of distance and duration and explore regions of reality that would otherwise remain forever beyond reach. Tonight, as we continue our gentle journey through the science of temporal mysteries, we'll explore what happens when these possibilities for time travel collide with the logical foundations of causality itself, leading us into the beautiful puzzles and paradoxes that emerge when past and future become as navigable as the rooms of your own home. Imagine yourself gently floating in a boat on the river of time, and suddenly discovering that this river curves back upon itself in impossible ways, creating loops and eddies where the water that flows past you now will eventually circle around to become the same water that carried you yesterday. And as you contemplate this strange temporal geography while resting comfortably in the soft darkness of night, you begin to understand why the possibility of traveling backward through time creates some of the most beautiful and perplexing puzzles that human minds have ever encountered. The most famous of these puzzles, known tenderly as the grandfather paradox, asks a simple question that opens doorways into profound mysteries about the nature of causality, identity, and the logical structure of reality itself. If you could somehow journey back through time to a period before your own birth and accidentally prevent your grandparents from ever meeting each other, how could you exist to make that journey in the first place? And what would happen to the timeline that created you if your very presence in the past erased the possibility of your own existence? This isn't merely an abstract philosophical exercise, but a genuine challenge to our understanding of how cause and effect operate in a universe where time travel might be possible, because it reveals the deep connections between events separated by decades or centuries, showing how your existence today depends on countless decisions and chance encounters that rippled forward through time to create the specific circumstances that allowed your parents to meet, fall in love, and eventually bring you into being. As you breathe slowly and let your mind drift through these temporal puzzles, you can picture yourself as a time traveler standing in your grandfather's hometown decades before he met your grandmother, watching him walk down a street toward the cafe where their eyes would first meet, and feeling the weight of knowing that a single word from you, a moment's distraction, could redirect his steps toward a different path that would cascade through the years to prevent your own birth and thus eliminate the very future that sent you back to observe this crucial moment. The paradox becomes even more intricate when you consider that your knowledge of family history, your ability to find your grandfather in the past, your very motivation for making the journey all depend on events that occurred after his meeting with your grandmother, creating a temporal loop where the effect your time travel seems to precede and potentially negate its own cause, your existence, challenging our basic assumptions about the arrow of causality and the logical consistency of any universe where backward time travel is possible. Physicists and philosophers have proposed several elegant solutions to this paradox, each offering a different perspective on how the universe might handle the logical complications of temporal travel. And these solutions read like poetry written in the language of space-time geometry and quantum mechanics. One possibility, known as the Novikov self-consistency principle, suggests that the universe has a built-in mechanism that ensures causality loops always resolve themselves in logically consistent ways. Perhaps every time you try to prevent your grandparents from meeting, circumstances conspire to bring them together anyway, as if the timeline has an immune system that protects itself from paradoxical changes by creating events that restore the original sequence of cause and effect. Another solution proposes that traveling backward in time actually creates branching timelines, alternative realities where your actions generate new histories parallel to the one you came from, so that preventing your grandparents from meeting in the past simply creates a new timeline where you never existed while leaving your original timeline unchanged, allowing you to return to a future that remains unaffected by your temporal intervention. The many worlds interpretation of quantum mechanics provides yet another framework for understanding these paradoxes, suggesting that every possible outcome of every quantum event creates separate, equally real universes, and that time travel might simply be a way of navigating between these parallel realities, allowing you to visit versions of the past that exist in different quantum branches of the universal wave function. Perhaps most beautifully, some theories propose that closed time-like curves the mathematical structures that would allow backward time travel naturally evolve toward self-consistent solutions through processes we don't yet understand, creating temporal loops where causes and effects arrange themselves in patterns that eliminate logical contradictions, like a cosmic editor revising the script of reality to ensure that every story makes perfect sense when viewed from the perspective of space-time as a complete, four-dimensional structure. These solutions to the grandfather paradox reveal something profound about the relationship between free will and determinism in a universe where time travel might be possible. If you could journey into the past, would you truly have the freedom to change historical events? Or would the very structure of space-time guide your actions toward outcomes that preserve the consistency of the timeline that enabled your journey? The question touches the deepest foundations of physics and philosophy, asking whether the universe operates according to fixed laws that determine every event, or whether consciousness and choice play fundamental roles in shaping the flow of temporal experience. As you rest here in the present moment, feeling the gentle rhythm of your heartbeat marking the passage of time in its familiar forward direction, you're participating in the same cosmic processes that create these temporal puzzles, living within a reality where every decision you make sends ripples both forward and backward through the fabric of space-time, influencing not just your future, but potentially creating quantum echoes that extend throughout the entire history of the universe. The grandfather paradox invites us to think deeply about identity and continuity, about what makes you you across time and through change, about whether the person who might travel back to meet your grandfather would still be the same individual who was born years later as a result of that grandfather's choices, or whether temporal travel necessarily creates questions of identity that challenge our basic understanding of consciousness and selfhood. Tonight, as we continue our exploration of time's deepest mysteries, we'll venture into the quantum realm where particles dance between past and future in ways that make the grandfather paradox seem almost simple by comparison, discovering how the smallest constituents of reality experience time in forms so strange and beautiful that they expand our vision of what temporal existence might truly mean. Descend with me now into the quantum realm, that mysterious kingdom smaller than atoms, where the familiar rules of time and causality dissolve into probability clouds and wave functions, where particles exist in ghostly superpositions of past, present, and future, until the very act of observation collapses their temporal dance into the single crystalline moment of measurement. And as you breathe slowly in the gentle darkness, letting your consciousness drift toward these tiniest scales of reality, you'll discover that time itself becomes fluid and strange in ways that make even the grandfather paradox seem straightforward by comparison. In this quantum wonderland that exists beneath the threshold of your direct perception, electrons don't simply move from one place to another through time like cars following a highway, but instead exist in what physicists call superposition states, ghostly combinations of all possible paths and all possible moments, experiencing every potential history simultaneously until something, a detector, a measurement, an observer forces them to choose just one timeline out of the infinite possibilities that quantum mechanics allows. The famous double-slit experiment reveals this temporal strangeness in the most elegant way. When you fire a single electron at two parallel slits, it behaves as if it passes through both slits at the same time, creating an interference pattern that can only be explained if the electron somehow experiences multiple histories simultaneously, exploring every possible path through space-time before settling into the specific trajectory that measurement reveals, as if each particle carries within itself a complete library of alternative timelines that exist in quantum superposition until the moment of observation collapses this vast potential into a single, definite reality. Even more mysteriously, quantum mechanics suggests that particles can influence their own past through a phenomenon called retrocausality, where the decision to measure a particle's property in the present can apparently determine what state it was in before the measurement was made, creating loops of causation that flow backward through time in ways that would be impossible in the classical world of everyday experience, but seem to be fundamental features of quantum reality. The delayed choice quantum eraser experiments demonstrate this temporal strangeness with almost magical clarity. Photons that have already passed through an experimental apparatus and should have decided whether to behave like waves or particles, can have their behavior retroactively determined by measurements made after they've completed their journey, as if the future reaches backward through time to influence the past in ways that preserve the logical consistency of quantum mechanics, while challenging our basic intuitions about the arrow of causality. As you rest here contemplating these mysteries, your own body is a vast quantum system where trillions of particles are constantly performing their own temporal dances, existing in superposition states that span microseconds or nanoseconds before environmental interactions force them to collapse into definite states, creating the illusion of a solid, continuous existence from what is actually a constantly flickering quantum process, where past and future blend together in ways too subtle for conscious perception but fundamental to the very structure of matter and energy. Quantum tunneling provides another window into time's strange behavior. At microscopic scales, particles can apparently pass through energy barriers that should be impossible to cross according to classical physics, disappearing from one side of a barrier and reappearing on the other side in a process that seems to involve spending negative amounts of time in the forbidden region, as if the particle briefly borrows time from the future to complete its impossible journey before paying back the temporal debt through quantum fluctuations that ripple through the vacuum of space. The quantum Zeno effect reveals how observation itself can manipulate the flow of time for quantum systems. By measuring a particle's state frequently enough, you can effectively freeze its quantum evolution, preventing it from changing or decaying. By forcing it to remain in a single eigenstate through the repeated collapse of its wave function, creating a kind of temporal imprisonment where the particle becomes trapped in the present moment by the very act of being observed. Perhaps most beautifully, quantum entanglement suggests that particles can share temporal experiences across vast distances, maintaining instantaneous correlations that seem to transcend the speed of light, barrier that limits classical communication. As if entangled particles exist in a shared quantum timeline that operates outside the normal constraints of space-time geometry, allowing them to influence each other's measurements instantaneously regardless of the spatial separation between them. These quantum temporal effects hint at deeper mysteries about the nature of time itself. Particles can exist in superposition states that span multiple moments. If measurements can influence past events, if quantum tunneling allows negative time intervals, then perhaps our everyday experience of time as a uniform, forward-flowing river is just an emergent property of large-scale systems, a kind of statistical averaging over the wild quantum fluctuations that occur at microscopic scales where individual particles dance freely between past and future. The many worlds interpretation of quantum mechanics takes this idea even further, suggesting that every quantum measurement creates branching timelines where all possible outcomes actually occur in parallel universes, so that the collapse of the wave function isn't really a collapse at all, but rather the splitting of reality into multiple branches, each containing a different version of history and a different version of you, who experienced that particular quantum outcome. Some physicists have proposed that consciousness itself might play a fundamental role in the quantum measurement process, suggesting that the act of observation that collapses wave functions and crystallizes quantum possibilities into definite realities might be intimately connected to the emergence of conscious awareness, creating a deep link between the structure of time, the nature of quantum mechanics, and the mystery of subjective experience that you're having right now as you contemplate these ideas. As you drift deeper into the peaceful rhythm of sleep, your brain's neural networks are performing their own quantum dances, with microtubules in your neurons possibly serving as quantum computers that process information through superposition, states and entanglement effects, suggesting that your consciousness might be directly connected to the quantum realm where time becomes fluid, and multiple realities exist simultaneously until the moment of observation collapses them into the single timeline of your waking experience. Tonight, as we continue our gentle exploration of temporal mysteries, we'll discover how these quantum insights about the nature of time connect to larger questions about the structure of reality itself, leading us toward a vision of the universe, where past, present, and future exist as equally real dimensions in a vast four-dimensional landscape that we're only beginning to understand. Imagine rising above the flowing river of time that has carried you through this journey, ascending to a place where you can see the entire temporal landscape spread out below you like a vast, crystalline structure that extends infinitely in all directions. And from this elevated perspective, you begin to understand one of the most profound and beautiful ideas in modern physics. That time might not be the flowing stream we experience, moment by moment, but rather a complete, eternal architecture where past, present, and future exist simultaneously as equally real regions of a four-dimensional space-time continuum that physicists call the block universe. As you rest here in the gentle darkness, breathing slowly and letting your consciousness expand toward this cosmic perspective, you can envision your entire life not as a sequence of moments that unfold one after another, but as a complete, unchanging structure that exists in its totality within the fabric of space-time, where your birth and your death, your first steps and your final breath, your moment of reading these words and every dream you'll ever have, all coexist as permanent features of reality's deeper architecture, like rooms in an infinite mansion that exists outside the flow of temporal experience. In this block universe model, the feeling of now that seems so immediate and special to your consciousness isn't a fundamental feature of reality, but rather a kind of spotlight that your awareness moves through the static structure of space-time, illuminating different cross-sections of your four-dimensional existence. As you travel along your world line through the temporal dimension, much like how a flashlight beam reveals different portions of a darkened room as you move it across the walls and furniture that were always there, waiting to be illuminated. This perspective transforms our understanding of existence itself. Instead of being temporary beings who briefly flicker into existence before vanishing into non-being, you'll become an eternal structure woven permanently into the fabric of space-time, where every moment of your life, every thought, every heartbeat, every act of love and creativity exists forever as part of the unchanging geometric pattern that is the complete history of the universe from its beginning to its end. The mathematical foundations of Einstein's relativity naturally lead to this block universe interpretation because they reveal that simultaneity, the idea that events can be meaningfully said to happen at the same time, is relative to the observer's frame of reference, meaning that what counts as now for you might be past or future for someone, moving at a different velocity or in a different gravitational field, suggesting that there's no universal present moment that divides past from future, but rather a complex space-time geometry where the temporal ordering of events depends on your perspective within the four-dimensional continuum. From this eternal viewpoint, time travel becomes not a matter of moving through time, but of accessing different regions of the block universe that already exist in their complete form, like turning to different pages in a book that contains the entire story from beginning to end, where every chapter is equally real and permanent, regardless of which page you happen to be reading at any particular moment. The block universe also provides a framework for understanding how quantum mechanics might work across time. If all moments exist simultaneously in the eternal structure of space-time, then quantum entanglement and retrocausality become features of the permanent geometric relationships between different regions of the block, allowing particles to maintain correlations across temporal as well as spatial separations because their entire histories are part of a single unchanging quantum state that exists in its completeness outside the flow of experienced time. This perspective offers profound comfort when contemplating mortality and loss in the block universe. Nothing is ever truly lost because every moment of existence remains permanently embedded in the structure of space-time, where your loved ones who have died continue to exist in their full reality within the temporal regions they occupied during their lives, and where your own consciousness, rather than being a fleeting flame that will someday be extinguished, becomes an eternal thread woven into the cosmic tapestry that persists throughout all of space-time. The emotional implications of the block universe can feel both liberating and melancholy liberating, because it suggests that every moment of joy, every experience of beauty, every act of kindness exists forever in the eternal structure of reality. But melancholy because it implies that the sense of possibility and becoming that gives life its dynamic quality might be an illusion, created by our limited perspective within the four-dimensional whole. Yet this eternal perspective also reveals the profound interconnectedness of all existence in the block universe. Every event is part of a single, unified structure where the Big Bang and the heat death of the universe, your first cry as a baby and your last word as an elder, the birth of stars and the formation of galaxies, all exist as aspects of one magnificent eternal pattern that encompasses the entire history of everything that ever was, is, or will be. As you drift deeper into the peaceful rhythm of sleep, your consciousness moving through its own temporal cross-section of the block universe, you can imagine your dreams as journeys through different regions of this eternal structure, where your sleeping mind explores alternative pathways through the four-dimensional landscape of possibility, visiting memories that exist as permanent features of your personal space-time geometry and perhaps even glimpsing potential futures that await you in regions of the block that your waking consciousness has not yet illuminated. The block universe suggests that time travel, rather than being a matter of changing the past or determining the future, would be a way of accessing different regions of this eternal structure, allowing consciousness to move through space-time, geometry and directions other than the forward temporal motion that characterizes normal experience. Though such movement would not alter the permanent architecture of the block, but simply reveal different aspects of its unchanging completeness. Some physicists propose that the subjective experience of temporal flow emerges from thermodynamic processes that create an arrow of time within the eternal block. As entropy increases and information becomes more distributed, creating the psychological experience of moving from past to future, even though all moments exist simultaneously in the deeper structure of space-time. Much like how a river appears to flow even though every drop of water in it occupies a specific, permanent location within the riverbed's geography. Tonight, as we continue our gentle exploration of time's deepest mysteries, we'll encounter theoretical particles that might move backward through this eternal block universe, carrying information from regions we call future to regions we call past, opening doorways to temporal communications that challenge our understanding of causality, while remaining consistent with the mathematical structure of space-time itself. Descend with me now into the quantum realm, that mysterious kingdom, smaller than atoms, where the familiar rules of time and causality dissolve into probability clouds and wave functions, where particles exist in ghostly superpositions of past, present, and future, until the very act of observation collapses their temporal dance into the single, crystalline moment of measurement. And as you breathe slowly in the gentle darkness, letting your consciousness drift toward these tiniest scales of reality, you'll discover that time itself becomes fluid and strange in ways that make even the grandfather paradox seem straightforward by comparison. In this quantum wonderland that exists beneath the threshold of your direct perception, electrons don't simply move from one place to another through time like cars following a highway, but instead exist in what physicists call superposition states, ghostly combinations of all possible paths and all possible moments, experiencing every potential history simultaneously until something, a detector, a measurement, an observer forces them to choose just one timeline out of the infinite possibilities that quantum mechanics allows. The famous double-slit experiment reveals this temporal strangeness in the most elegant way. When you fire a single electron at two parallel slits, it behaves as if it passes through both slits at the same time, creating an interference pattern that can only be explained if the electron somehow experiences multiple histories simultaneously, exploring every possible path through space-time before settling into the specific trajectory that measurement reveals, as if each particle carries within itself a complete library of alternative timelines that exist in quantum superposition until the moment of observation collapses this vast potential into a single, definite reality. Even more mysteriously, quantum mechanics suggests that particles can influence their own past through a phenomenon called retrocausality, where the decision to measure a particle's property in the present can apparently determine what state it was in before the measurement was made, creating loops of causation that flow backward through time in ways that would be impossible in the classical world of everyday experience, but seem to be fundamental features of quantum reality. The delayed choice quantum eraser experiments demonstrate this temporal strangeness with almost magical clarity. Photons that have already passed through an experimental apparatus and should have decided whether to behave like waves or particles can have their behavior retroactively determined by measurements made after they've completed their journey, as if the future reaches backward through time to influence the past in ways that preserve the logical consistency of quantum mechanics, while challenging our basic intuitions about the arrow of causality. As you rest here contemplating these mysteries, your own body is a vast quantum system where trillions of particles are constantly performing their own temporal dances, existing in superposition states that span microseconds or nanoseconds before environmental interactions force them to collapse into definite states, creating the illusion of a solid, continuous existence from what is actually a constantly flickering quantum process, where past and future blend together in ways too subtle for conscious perception but fundamental to the very structure of matter and energy. Quantum tunneling provides another window into time's strange behavior. At microscopic scales, particles can apparently pass through energy barriers that should be impossible to cross according to classical physics, disappearing from one side of a barrier and reappearing on the other side in a process that seems to involve spending negative amounts of time in the forbidden region, as if the particle briefly borrows time from the future to complete its impossible journey before paying back the temporal debt through quantum fluctuations that ripple through the vacuum of space. The quantum Zeno effect reveals how observation itself can manipulate the flow of time for quantum systems. By measuring a particle's state frequently enough, you can effectively freeze its quantum evolution, preventing it from changing or decaying, by forcing it to remain in a single eigenstate through the repeated collapse of its wave function, creating a kind of temporal imprisonment where the particle becomes trapped in the present moment by the very act of being observed. Perhaps most beautifully, quantum entanglement suggests that particles can share temporal experiences across vast distances, maintaining instantaneous correlations that seem to transcend the speed of light, barrier that limits classical communication. As if entangled particles exist in a shared quantum timeline that operates outside the normal constraints of space-time geometry, allowing them to influence each other's measurements instantaneously regardless of the spatial separation between them. These quantum temporal effects hint at deeper mysteries about the nature of time itself. Particles can exist in superposition states that span multiple moments, if measurements can influence past events, if quantum tunneling allows negative time intervals, then perhaps our everyday experience of time as a uniform, forward-flowing river is just an emergent property of large-scale systems, a kind of statistical averaging over the wild quantum fluctuations that occur at microscopic scales where individual particles dance freely between past and future. The many worlds interpretation of quantum mechanics takes this idea even further, suggesting that every quantum measurement creates branching timelines where all possible outcomes actually occur in parallel universes, so that the collapse of the wave function isn't really a collapse at all, but rather the splitting of reality into multiple branches, each containing a different version of history and a different version of you, who experienced that particular quantum outcome. Some physicists have proposed that consciousness itself might play a fundamental role in the quantum measurement process, suggesting that the act of observation that collapses wave functions and crystallizes quantum possibilities into definite realities might be intimately connected to the emergence of conscious awareness, creating a deep link between the structure of time, the nature of quantum mechanics, and the mystery of subjective experience that you're having right now as you contemplate these ideas. As you drift deeper into the peaceful rhythm of sleep, your brain's neural networks are performing their own quantum dances, with microtubules in your neurons possibly serving as quantum computers that process information through superposition, states and entanglement effects, suggesting that your consciousness might be directly connected to the quantum realm where time becomes fluid, and multiple realities exist simultaneously until the moment of observation collapses them into the single timeline of your waking experience. Tonight, as we continue our gentle exploration of temporal mysteries, we'll discover how these quantum insights about the nature of time connect to larger questions about the structure of reality itself, leading us toward a vision of the universe, where past, present, and future exist as equally real dimensions in a vast four-dimensional landscape that we're only beginning to understand.